There's a mirror. Wow, there's a mirror on this side.
Oh, no, we're good. So Holochain has a core team of up to almost 40 people now, distributed all around the world. Philip happens to be in Melbourne. So we thought we would take advantage of the same time zone. He also gives a really mean overview of the whole kind of crypto space and where Holochain might fit in that. So it's a presentation that kind of spans both a business and a technical audience. So
Cool.
yeah. Thanks, Phil. Talk to you soon.
Thank you. All right, welcome everybody. Like Belinda said, this is going to be a bit of a whirlwind session, so get your brains on. So I got a bit of a disclaimer to start with. This whole crypto space is pretty much the Wild West of the internet. It's really quite complicated, so don't worry if you don't understand a lot of what I'm going to talk to you about. And it kind of feels to me like internet 1993, 94, you know, like where it existed, a couple of apps worked on it and some people knew about it, but nobody had any idea that 20 years later you'd have to be completely internet connected to be a successful business in any way, shape or form. And I've written there that I feel like I can see some of the matrix. It's because I had the opportunity to work with Art Brock for 4 weeks. And at the end of that 4 weeks, I kind of felt like Neo when he goes, you know, I know Kung Fu. But what's happened, but what's happened in the last couple of weeks is I've actually figured out a few more things. So I'm starting to get toward the ends of those movies. So what we're going to cover is some things here: Bitcoin, blockchain, proof of stake, some Ethereum, Holochain, and our ICO. So cryptocurrencies. So this has become on everybody's radar in the last few years. And essentially what we've got here is this concept of Bitcoin where people mine it and then they get coins from mining it, and then we're supposed to be able to use it as a currency. If you don't know what it is, that extremely long list of letters and numbers is a hash key. And that's what a Bitcoin address looks like. Now, what the miners are trying to do is run that hash key so many times until they get 5 zeros at the beginning. So you can imagine that would be quite a bit of work to do, which is the whole proof of work thing. And we'll get onto that a bit more. So I wanted to kind of demonstrate here a bit of the volatility of this as well. So we'll look at these. I've got 3 price lists to show. So this is November. I've got 2 in April coming up. With all these cryptocurrencies, you have a thing called a wallet, which is essentially a piece of software with that kind of address at the top there. And people can move these Bitcoins or Ethereum or whatever these coins are around in a decentralized network using these wallets. And you can also exchange these for state money on exchanges. And you can buy these things and sell and trade them. And in Australia, they're classed as an asset. So if you keep it for longer than 12 months, you only pay 50% because you've got capital gains tax. And what's an ICO? So basically an ICO is the new way to raise funds for these kinds of projects. It stands for initial coin offering. And instead of you buying equity and shares in a business, you buy coins. So let's have a quick look at the pricing here. So this was November 2007. It was $10,000. In December, it went up to nearly $20,000. Then in April, at the beginning of this month, it was $6,800. And as of today, it's $7,900. So you can see that it's lost 50% in 3 months. So that's a pretty unstable market. And I really like how the whole crypto space is calling state currency fiat, because they're trying to differentiate between cryptocurrency and this fiat state money. What fiat means is breathed into being, and all these crypto coins, they're all breathed into being. They're just made by mining. And so the whole place is pretty much a gambling chip. You know, I've bought some Bitcoin down to this price here because I reckon it's going to go up, as has everybody. But it's not very good for actually being a currency because it's too unstable. And the problem is that in the 10 years since Bitcoin came on the market, it's managed to concentrate a whole lot of wealth into the hands of a very small few people, much faster than state currency did over the last couple of 100 years. And part of the problem with that is that the currency itself is not what we call value-backed, and I'll discuss that a bit later on. All right, so what is a blockchain? A blockchain is literally a chain of blocks, and in the block is a list of transactions. And what happens is that on that diagram there, you can see all the different nodes in a Bitcoin network. And what happens is that when you make a transaction with your wallet, the transaction goes to a bunch of nodes in the network. And when the block is full of enough transactions, then the miners process the block. And what that means is that they get the last committed block out of the blockchain, and also the current committed block out of the blockchain, the new list of transactions, and they combine those two pieces of data together. And they use this really clever piece of cryptography software developed by the NSA, of all people, to do what's called a hash. And what that means is you can run this algorithm against any piece of data, and it will always return exactly the same hash key, which is what that long string I showed you before, because it's deterministic, which means that if you change it, then you'll get a different value. So what the miners are doing is that they get the existing block and the new block of transactions, and then they change this thing called a nonce. And every time you change the nonce, you get a different hash key. And what they're looking for is that hash key with 5 zeros at the beginning. So there's a fair bit of mathematics to do in that. And what happens is that the big mining farms have special hardware, and the hardware, the actual chip itself, has the algorithm built into the chip. So there's no software. So that's like super fast. And what they've been able to do is, at the moment, the fastest one they've got does 17.5 terahashes per second. And in some of the big farms, there's lots of these things. So that's lots and lots of calculations, all trying to find this zeros at the beginning. And actually, I need to update that because it's not 0.1 anymore. I think it's closer to 0.3 of the Earth's electricity is now wasted on these mining farms. And it's crazy. And this whole idea that it was supposed to be decentralized, the proof of work algorithms and proof of stake are actually centralizing, because once the coin that it's based on starts to grow in value, then it becomes more enticing to go faster. So there's this arms race in how fast your chips are. And I mentioned that some of the farms are getting quite big. So this is probably one of the biggest ones I've been able to find. It's a company called Bitmain, and they've got this farm here. So these are massive warehouses full of millions of those chips that do 17.5 terahashes a second, right? So they're all trying to find that zeros. And this is located next to a hydroelectric dam. And he also owns the company that manufactures the chips. So you can see why I'm saying that it's it centralizes power, because you and I can't compete against that to mine a Bitcoin anymore. All right, so in the crypto space, you hear about altcoins all the time. What that essentially means is that it means it's not Bitcoin. And what's happened is that over time, Bitcoin is what's called open source. So the source code for it is published, as is all the data. So if you, and you can do what's called a fork. And what happens in a fork is you can imagine two accountants working in an accountancy firm together, and they've both been working on the same list of clients for the last 5 years. And one of them decides that they've got a better way of doing it. So they talk to each other, and after a while they decide that they're not going to work together anymore. And the person with the different way of doing things takes the list of customers, and now they both have the same ledger of all the transactions that have happened, but now they're different companies. So now they're split, or they're forked. So that's why when things like Bitcoin forked to Bitcoin Cash and to Bitcoin Gold, when when it was forked, you got as many Bitcoin Cash as you already had in Bitcoin. So basically, people are getting free money for these at this point. Yeah, so that's forks. So the next thing you might have heard about is this thing called Ethereum and the idea of distributed applications. I did hear somebody mention that before. And what the promise of this was that it got all these computers around the world that are doing this, all this mining for Ethereum, because Ethereum is an altcoin. And what they did was they figured out a way that you could actually process, instead of just transactions, you could process code, which they call a smart contract. So what happens is that you commit smart contracts to the blockchain, and then when it gets processed, whatever logic you had in there gets executed. Usually things like, transferring money around and that sort of stuff. And the promise of that was it's supposed to be this worldwide computer. The problem with that is that because everybody's data is on everybody's machine and everybody's programs are around there, the blockchain got kind of big. So let's have a look at that. So the size of the blockchain, they don't publish it anymore. It used to be on a site called Etherscan, but now they just have what they call the fast sync one there. And the fast sync is basically just the last couple of weeks of transactions. So you have to trust that all the previous transactions were correct. And the problem with trying to become a full Ethereum node now is that even if you've got a really fast setup, it takes about 4 weeks to download the block and to also then reprocess all the transactions so that you can prove that the block hasn't been messed with. Kind of slow. You've also got this problem of gas limits. So you can't process too much inside a block that gets commuted on the chain because you get charged more in Ether. And which means that you then have to break down your processing into these small blocks and wait, a couple of minutes for each one of them to get processed, which makes things a bit slow. And Vitalik, who's the creator of Ethereum, was actually just quoted last week as saying, Ethereum apps are being screwed by scaling. What that means is this concept isn't going to work. All right, so this is the size of the blockchain. This was November last year, about 400 gigabytes. There's nearly half a terabyte, right? That was in November. In April, they'd stopped publishing the big one and we're publishing this, what they call a fast one. And this is, as I understand it, about a sixth of the size, maybe a seventh or eighth or something of the size of the big one. So this is getting up around 500 gigabytes. And the number of users in that time was only about 25 million. So that's a lot of data for not a very big user base. So we like to say, think outside the blocks. We've got the word chain in our Holochain, so the first thing people will think is that we're a blockchain, but we're not. And I'll tell you why. So I had this thought today about what's going on in the world, in society. And if you think back over the last, say, 15, 20 years, so the internet had what we'll call a Precambrian explosion of products. When it first came on the market, everybody remembers the dot-com bubble. So that money that was in that whole space, that went to the few who knew the system. And that money generally came from the crowd. But the good thing about that was that the internet gave people a new way to think. There's this idea of being connected now. Then we had real estate, which had a Precambrian explosion of all those subprime mortgages and all that kind of stuff. And there was lots of money involved there again. And again, that money went to the few who knew the system, and that money came from the crowd, which was us. But the GFC made people uncomfortable enough to actually start to look for change. Now, this crypto space, it's having its own Precambrian explosion of products and services, and there is lots of money involved. We're talking $500 billion here so far. And that money, again, is going to the few who know the system. And again, it's coming from the crowd. So all that FOMO that I heard, that you hear people talking about, fear of missing out. People who don't understand what's going on are buying in at the wrong time and basically losing all their money. But at this point, we're learning about that distributed crypto collaboration. It does start to make real change. There's an opportunity here to do like distributed autonomous organizations where you can code up how an organization works. And you don't have to worry about people getting involved and being corrupted and that sort of thing. So there's this new way of thinking now. So what's happening now is that the Holochain ecosystem is about to enter its Precambrian period, and there'll be an explosion of different types of apps built on Holochain. And what that's going to provide is lots of value. The stark difference here is that the value that is generated in this ecosystem is peer generated. And not only that, that value goes back to the peers and the crowd. And what we're learning is that this distributed value creating collaboration can change society. Because when people can be rewarded for providing value to a network, they can make a living out of it, and people's expectations of life change, and the way that they interact with each other changes as well. All right, so how's Holochain different? I only found this out a couple of days ago, but the first white paper about Holochain was actually published before the Bitcoin one. It's kind of cool. So the way it's different, its primary difference is that it's agent-centric. There's no global ledger. Holochain itself doesn't have a currency. We've built one on top, or we're building one at the moment called Holo. So there's no global ledger. We don't have any problem with scaling. The reason for that is that we use a tried and tested system called a distributed hash table. It's based on an algorithm that was developed in 2002 and basically hasn't changed since then because it's so good. And it's like BitTorrent. And so that distributed hash table, we call it DHT. We've added some new features to it, and now it's self-healing. It's also self-validating, and you can make private DHTs as well. There's no mining involved, which means that there's no proof of work, and there's no proof of service, and there's no wasted power, which is something like 0.3 of the world's power generation at the moment, which is just insane. And we have this idea of sharded DHT so that you can spread files around so that downloading and accessing things is really fast. And when I say it's scalable, what I mean is it's inversely scalable, because as people join the network, because all the processing is done locally on their machines, they actually bring more computing power than they're ever going to use, which means that the more people that join, the faster things go. And we've actually designed the Holo system to do billions of transactions per second, not 7, like Bitcoin does. And it works offline natively, so the apps all work independently of the internet, and when they're connected, the self-healing part of the DHT will start to update data and sync data for you. It's got a built-in test framework for doing synchronous testing and also multi-node scenarios. Because it's peer-to-peer, you have to have a way to test when 5 different agents are all talking to each other and what's actually going on in the network, and that's all built in. You can build your own test network as well with Docker, so I'll show you that a bit later as well. And you can pretty much use your existing web skills. You can write JavaScript, then you can call the API Holochain and build your apps. And we use this idea of biomimicry because nature's running a pretty good distributed system at the moment, and we'd like to try and emulate some of that in software. And I'm going to go into that a bit later, but next thing I wanted to show you was Nicholas Luck. He is one of our main developers, and he did this really cool video on how Holochain works this morning. So I'm just going to stop recording for the moment.
Okay.
Somehow, how do I do it? There you go.
Hi, my name is Nicholas Luck. I'm one of the Holochain core developers, and in this video I would like to give you a quick and concise 5-minute download of what Holochain is and how it actually works. Holochain is a framework for building fully distributed peer-to-peer applications. You could think of it as like a Ruby on Rails, but instead of spitting out something that runs on a centralized server, it creates a fully distributed peer-to-peer network customized for your application. Important to mention here, Holochain is not blockchain. Holochain takes an agent-centric approach, while blockchain is data-centric. With blockchain, every node of a network maintains the same state of the network, the one objective global truth, the consensus that actually is protected by a lot of work, and that makes it possible to think of the system as like one global database or one global computer. But that is actually also the reason why blockchain has scaling issues. If every Bitcoin node on this planet has to validate and synchronize everybody else's transactions, well, that is why there is a transaction per second limit in every blockchain. Nobody would ask how many HTTP transactions the internet is able to handle each second, because there is no one bottleneck. But the limitation that comes out of this basic approach of blockchain has already primed the perception of what distributed applications and architectures are able to deliver. Holochain is not doing that. Holochain does not force consensus over the whole network. Instead, following this agent-centric approach, each agent is maintaining his, her own history. So there still in Holochain is a chain, a hash chain like the blockchain, but each agent has its own tamper-proof hash chain. So everything an agent is saying or doing, so if it is a social network, it would be posts or it could be transactions of a cryptocurrency, every action that an agent is undertaking is being stored in its hash chain. So Holochain is actually pushing this chain aspect from the center of the network to the edges. This is very similar to Git, for instance, but with one very important addition, and that is signatures. Everything that an agent authors is being signed by the agent's private key. So an agent's source chain plus the private key is actually what in Holochain represents an agent. This could be already sufficient for several applications, like for instance a Git on Holochain or an identity management application in which entries are only being stored via node-to-node communication, and the main concept needed here is the tamper-proofness of the hash chain of each agent. But for most applications, we need something else. And that is why Holochain also implements a DHT, a distributed hash table, as the public space. The same thing that is being used in BitTorrent or IPFS, for instance. The problem with only using source chains would be that if a node goes offline, then all the contents are not accessible by other nodes. But if we, for instance, want to implement a social network on Holochain where published posts are being accessible by everybody else, then we need other nodes to also store entries otherwise only stored in the author source chain. And in order to make sure that these entries are always accessible, Holochain maintains a certain number of redundant copies for each entry, where this number is a parameter that can be set for each application. This enables the author to go offline while still somebody reading the post could get the entries from the DHT. Now, the third thing next to the source chain and the DHT that is being combined here in order to enable high trust applications like cryptocurrencies is a distributed validation of content. Let us look at an example here. So say we would have an agent that is trying to hack the system and maybe post in the name of another user, or that is trying to make a currency transaction that is not valid. And suppose this agent has hacked its own software that is running locally in order to create these malicious entries, would be now trying to share these entries in the public space via the DHT. Every node in the DHT that is receiving an entry to store first runs the validation rules of that application. We actually call the code that makes up an application DNA. And the core of that are the validation rules. They are called DNA because that is what every node of an application needs to share. So you could say actually that there is consensus also in a Holochain app, but it is consensus about the validation rules. The attacker now obviously is running different validation rules locally, which made it possible for him to create this malicious entry. So in a sense, by changing those validation rules, this attacker forked into a different app. Now the validating DHT node applying those validation rules will find out that this entry is not valid. Now, being agent-centric and having a strong representation of agency means in this case here that this malicious entry actually holds the signature of the attacker. And that is a fact that now can be leveraged in something we call immune system. So now the DHT node that encountered this invalid entry is going to gossip with its peers and sharing its findings, which are actually cryptographically signed proof for the misbehavior of the attacker. Each of these nodes is now able to apply their copy of the validation rules and confirm that this entry really is not valid. Depending on the membrane and immune system settings of this app, this could lead to having the whole system stop communicating with the malicious actor. But we believe there is no one-size-fits-all solution that should be applied for all apps. So for instance, for our Twitter clone Clutter, there's no need to take such drastic measures if somebody tries to tweet a tweet that is longer than 140 characters or 280. The abstract concept of this management of members of a network is something we call membranes. Since we are agent-centric, we can do much more sophisticated stuff than just being permissionless or permissioned. Membranes could be non-existent, or defining a closed group, or could ask for a certain reputation in a different app, or have a certain number of people vouch for you to enter, or actually could resemble something like proof of work or proof of stake. For Holo, we introduced proof of service, which is kind of like proof of work, but the work is not a hash crack, but actually showing a history of having served other people's app under this agency. And again, Holochain is a framework for distributed apps. So everything that comes out of Holochain is an app. So with every DNA that represents a certain app, a new network is being created. It is like having your own blockchain for each smart contract. And now each agent can be part of many networks and talk to different other agents through these networks. A more fitting metaphor for a Holochain application would be a language. By installing an app, by installing the validation rules, the DNA, your agent learns to speak this language to other agents which also speak this language. Bridging between apps always happens through an agent that is able to speak both languages. I've said earlier that Holochain is not blockchain. But with Holochain, you could actually build an app that is a blockchain. I actually intend to build a Bitcoin clone on Holochain that is using Nakamoto consensus and proof of work. So in a sense, Holochain is meta with regards to blockchain. Or to put it differently, blockchain is just one of maybe a host of different distributed design patterns that become possible with Holochain. I'm sorry I passed the 5 minutes. If you want to dive deeper, I have some links here for you. Please check out my Medium article in which I'm talking about agent-centric applications and an idea of how the Holochain ecosystem could evolve. You can find the Holochain white paper at holochain.org, developer documentation if you want to start building your own app at developer.holochain.org. Please also check out holo.host, which is our flagship app, distributed cloud hosting on Holo, including an agent-centric cryptocurrency. And you can reach me in our Telegram channel as well as in our team chat under my nickname Luxus.
All right, so that was Nicholas on Holochain. Next up, we're going to actually build an app. So what I'm going to show you here is the app that Belinda built in less than a day. Nice one. This app is actually a next generation peer-to-peer distributed crypto app, and what she built is actually easily capable of supporting billions of transactions per second. It's a bit of a mouthful, but let's have a look at what we did. So let's escape out of here. So Nicholas and Belinda came down to both of the hackathons in Melbourne and Sydney, and in Melbourne I worked with Belinda, and Belinda explained to me her idea of building a journalist system where the articles could be cross-referenced and proven to belongs to someone, but you could use signatures and all this kind of cool stuff, and to make sure it couldn't be bleached from the internet. And it was a system called Unmute. And I'll show you what we did. So Holochain, it's installed, so don't worry about that part yet. I'm just going to show you how to build an app. And to install, it's pretty simple. It's just some binaries that we built. So you can just cut and paste them on. But to build an actual app, we've got this scaffolding tool at the moment. And what you can do is come in here and give your application a name and a description. And remember before I was talking about biomimicry. So what we've done is that Nicholas talked about it as well. You build up your applications, which we call DNA, with zomes, and that's short for chromosome. And I'm going to go through that whole process a little bit more after we've done this. So add a zome, and I can't remember what it was called, so we'll just make one up. Again, give it a description, and you can do what's called a zome entry. So this is the data structure that you're going to save into Holochain, and we'll call that data. And we want to create, read, update, and delete. And that's enough. So that was enough to build it. So then what you do is you download the file that we created. And when I ran so then there's a tool that we ran to process that package, and it created this application. And then what Belinda did is she went through here, and so each one of these is a zone that we created. So if I'd had the right ones in that scaffolder, that would have showed up here really well. So we've got 3 zones: citation, identify author, and publish. And each of these is just in JavaScript. So here we go. You know, if we want to create a citation, call that method, and commit is the Holochain API. So what we're saying is here, commit this thing called a citation, and it's this object, and we'll return the hash key. So what happened is that when you commit that piece of data into Holochain, it'll run that hash algorithm on that piece of data and gives you one of those hash keys. And then you can use that hash key to later on read it, which is read. Yeah. So you get all of this stuff from the scaffolding tool. And what I've discovered is that test-driven development, which I've been doing for years, works really well in this process. So what that means is that you write tests to work out work on your code. So here we've got a test, and it's nice and pretty. Right. So here we're saying I've got a test that says register yourself as an author so you can create articles. Cool. The name of the zone is identify author, which is this one just here. And there's a function in there called person create. So if we go and look in here, we should find a method called person create, which we pass this thing called a person entry. So if we look at that, this is what a person looks like. They've got a name and an ID and something called tags. All right. So when we do the test, I've got my zone and the method, and this is what we're going to input. So remember it had name, ID, and a list of tags. So that's what this one's got. And what we're expecting is that when we save that object into Holochain, the result is going to be the last hash key in the chain of hash keys, which is what H gives you. If you do H1, you get the one before that, H2, the one before that, etc. There's a whole bunch of strings that you can test, but we don't need to go into that. So what Belinda's done here is written some tests. So we can run these tests by doing HCDev test, and that is our Holochain development environment. Run that, and you see you've got all these tests. So that's that first one there. Register yourself as an author so you can create articles. And here we've got some debug information and whether or not it passed. Now, the beautiful thing about doing this is that you can write these tests and build your code in a really professional way. And this is a really fast way to work as well. And it's also 2 steps forward, no steps back. All right, so once Belinda had written some tests to prove that all the code she'd written back here was working as it should, then we needed the front end. So if we have a look in here, remember Belinda wrote all this. So this is just a standard HTML form with some text fields on it. And it's calling, there's some JavaScript down here. So we're calling there's a button called submit entry, and we're gonna click it. And when it does that, it's gonna save into Holochain and come back. So we can have a look at that by running HCDev web. And what this will do, this actually runs the Holochain web server for your whole Holochain app. So if we run that one, you'll see here this hash key. Now what's happened here, and Nicholas mentioned it, is that when you combine all of your code, which is your 3 zones here, with the contents of this file, and you do that hash algorithm, remember this is some data, so you can run the hash algorithm on it, you get this hash key. And the cool thing about that is that this hash key means that only people with exactly the same code can talk to each other, because that's the only way they can generate this hash key, because it's deterministic, so it's only one way. And so now we can go and look at Belinda's app on a browser. New tab. And if we go to localhost, because this is all running local, and we'll check out 3141, you can see here this is Belinda's app. And if you type stuff in here, and I submit my ID, and I will submit, you can see this is the hash key that was created. Now, if we do a read, read, we should put the value back. Oh, it doesn't work. Okay, you get the idea. So the really cool thing about this is that I wasn't kidding. This is a next-gen peer-to-peer app that will do billions of transactions per second. And the reason I can say that is because the transactions happen between two people. You're not waiting for this big blockchain to update and all that kind of stuff. You can actually do transactions at the speed that your computer will do them at. All right, so that is building an app. You can't actually do that. You try and do this on Ethereum, it takes forever. The really interesting thing about that is that you have to actually buy time on their testnet, whereas here you can run your everything local and you don't need to buy any testnet. And there's really cool ways of doing multi-node tests and stuff like that. All right, so the next thing I wanted to look at was, so we built an app, and that was, Belinda did that mostly herself in the space of a day, and that is the basis for the application that she's starting to build.
I supervise.
Yeah, that's right. What I wanted to have a quick look at is some of the tools that we've got in Holochain so that you can start to understand what's going on with this. I want to look at the idea of this chain of hash keys and how the validation in the DHT works. And we're going to look at something called Gossip. And I'd also like to look at some of the engineering that we're doing in the app space. So we go and look at the Holochain website. Smaller so you can do that. Right, so here we have this idea that Nicholas was talking about of a source chain. So this is where you write things. So every one of these E's is like an entry. So when we saved that, the ID and stuff in Belinda's app, that's what happened there. And I'll show you that in a sec. And then, so there's consecutive entries. And then this is the DHT. So what this represents is all of these nodes in the circle, they're all running on that same hash key that we were talking about here. And they all communicate with each other. And we have a thing called redundancy, so we work out how many nodes to work on and all that kind of stuff, and that's all managed by the BitTorrent algorithm. So we don't really have to do much in that space, and we get this really super fast way of doing things. But what I wanted to show you was chain. So we just ran Belinda's app. So if we run one of the tools, what this one is going to do, it's what we call dump. And this will actually dump the contents of the chain for us. And then we've got this cool tool called xdot. And what they give you is, I should have not Clutter dot, it was called, there we go. All right, so in here we have the Genesis block, and that's the block that gets all your code and makes the hash key out of it, and that's what this entry value is at the bottom here. Just have to see it bigger. And then the next one is the agent ID. So that's the agent is actually making the entries, and you can see that again that's hashed again. And the agent ID is specified out here. So this is my computer, Philip Beadle, Philip's MacBook Pro Local. And this is my public key that was generated for me, used for the cryptographic stuff. And then here you can see is our first entry. And this was what I typed in. Remember I typed in my ID and type your name here, Phil. So what happened is that gets saved into the Holochain source chain as that entry. And then this is the hash key for it. Now what you can do now is we can trace these hash keys back through the system. So this one here, this bottom one, entry, which ends in 7KTG. Should be somewhere. No, I've gone the wrong way. Yeah, so this one here, the hash of this header is this long one here, which ends in CYLA. Now you can see here on, this is the next header. So what that allows you to do is you can check to make sure that if you rehash this, you should get the entry key, and then you'll also be able to go back through the chain of hashes, hence the hash train. I know it's a bit complicated, but I really wanted to show you that the difference here is that this is written to your local machine. You've actually got a file on your app when you run this called ChainDB, and it has this information in it. And then what happens is that the DHT shares that information to everybody else on the same network.
And so, Phil, what's the implications of that?
The implications are that the minimum amount of data gets moved around. So if you go and look at the way a Bitcoin chain, a Bitcoin node works, every 1 megabyte goes up and down to the network 8 times. So you're transferring 8 megabytes of data to figure out for this one block. We don't do that. What happens is that we write locally, and then because this entry was marked as a public one, the distributed hash table, which is the most efficient data algorithm we've managed to come up with so far, disperses the data throughout the network. And so imagine if you've got, you set a redundancy of, you need at least, say, 20 copies of your entry in the network to trust that even when people are offline, you'll still be able to access that data. That's what the algorithm does, so it figures out which nodes to go to. That's a really good way, it's a really strong way of doing data transfer, and what I'm about to show you is the validation stuff. So Nicholas was talking about the self-validation. So if we go and look in the code, the zone that we were looking at before, that Belinda wrote, when you do this commit function, what happens is that we're saving this thing called a person and that entry. So it's this whole thing. You get this header and the entry. Remember that while I show you what's going to happen. So once we do commit, we go down to the validation rules. And what happens is that when you save your data locally and it goes into your node of the DHT then looks around in the network and finds a number of nodes that it's going to store a copy of this data on so that you've got resiliency and speed. So what happens is that the node that gets contacted runs a function called, next one down, validate package. When it's marked as null like this, what happens is you get the default entry, which I'll just remind you is this one here. So you get the header and the entry together. And then once it's got the validation package, it reruns validate commit. So now the node that's being asked to store the data is running exactly the same code that you ran when you committed it, which means that if they match, i.e. it generates the same hash key because nothing's been altered, it gets saved into the DHT as a validated piece of information. This is critical because what this allows, this gives you trust, because it means that all the other nodes that are storing your data have validated it. And as Nico showed before in his video, if somebody tries to mess with that, then we know who you are because you signed it, right? And we've got your, and yeah, so there's a signature on there so that we know who did it, so that then we can, if you need to, you could issue a warrant against that particular agent and say, look, this person's messing with stuff, so don't transact with them anymore. All right. What was I going to show you next? Gossip. All right, so that's fun. That's running Belinda's little app that she wrote by herself. So if we go and just turn a few of these things off. What I wanted to show you next was how to use a tool called Docker. So Docker allows you can make these basically little Linux boxes that run on your machine and run as many as you like. And what I'm doing here is I'm going to run an instance of our app that Nico talked about called Clutter. And it's basically a Twitter clone. And what I'm going to show you is some of the logging that goes on. And yeah, I'll show you the logging. So let's have a look at that. If I run this, you can see that it's creating 3 different versions of Clutter. I've got Clutter 3, 2, and 1. Clutter 1. And all this is I've turned on the DHT logging. So what you can see here is we've now got 3 Clutter nodes running, and they're all talking to each other. You can see that they're adding each other's peer IDs and they're talking to each other. So when I make a change in one of these nodes, then that information will get passed around. So if I now go and run a different app, here's a node of Clutter, and the settings, and I add my name in here to set my handle, and we'll switch back to the terminal. See here, it just, oops, wait. It talks a lot, and it talks really fast. Lost it. Oh, no, there we go. Put package, right? So you can see that it's the DHT is talking and doing what I said. So we're doing the link, and DHT is talking to each other. And so this is how the data gets around. So now if I go and run another node, and I'm going to run that one on 5141. The reason I know that is because I wrote this, and if you look at the top, right at the very top of here, you'll see that it's serving out for the different apps on the different ports, which I'm not going to talk through that, but you get the idea. So now we've got this one. So you can imagine that these 2 people are in a network. All right, so Belinda is in there, and so am I. So if I follow Belinda, and then Belinda makes a post. So there's Belinda's post, and if I go back to mine, you'll see that I'm seeing that as well. And that's all going through the DHT using Gossip. So you can look at all you can see the logging and all that kind of stuff that's getting moved around. And it's nice and quick.
So Phil, can you just reiterate or tease out from that what the advantages are of Clutter, which is a decentralized version of Twitter, over Twitter?
I will, but not yet. I've actually got a story about that. So we'll get into that. All right, and I just wanted to show you some of the engineering that we're doing around it. So got a bunch of tools. One of them is called Storybook, and that allows us to build UI components really well, like separate from the application. And it gives us a component library. So you can see down the bottom here, I'm telling you what this control does. Specifications are functional tests that are actually operating on this UI. And the action logger shows you what happens when you press buttons. You can we've got some really cool fun things here like autocomplete and all that kind of stuff. So this is using a JavaScript framework called React, which a lot of websites are written in. And the really nice thing about this is because these apps run locally, they run really, really fast. So you can follow all these good practices around development and engineering and build really cool Holochain apps. All right, next thing. I'm not going to go into it now, but there's a video that I can put in the links to, and that shows a conversation I had with another developer at Holochain about the benchmarks between Ethereum and Holochain. And the reason we did that was because we've got all these projects to show how much faster things are on Holochain, and the cost, like the cost of hosting things on Holochain as opposed to Ethereum. We've got explanations on that about why we're really confident saying that we're about 10,000 times cheaper. All right, next thing. I just wanted you to have a think about this. Right? You think about your daily life on the internet. Pretty much most of the stuff that you interact with is crowd-created content. You know, you look at Facebook and Twitter and all of these messaging apps and Snapchat and things like, you know, blogs and all these kinds of things, right? and we're the big contributors. Us people using the internet, we're creating most of this content, and it's going onto sites like Facebook and that sort of thing, and they're making huge money out of it, and we're not getting paid. So the reason they can do that is because one of the reasons that Holochain is different is that on all these other apps, it's kind of like it's somebody else's application. Like you're using Zuckerberg's Facebook app, and he's storing all of your data. And we have, like sheep, you know, we've let them get away with that for the last bunch of years because no one really understood what was going on, or actually how creepy the whole thing really is. So what I would like to have a chat about now is the idea of biomimicry and why Holochain is based on this idea. And this next bit is kind of like an idea that I've come up with over the last couple of weeks about how to explain Holochain and why it's different. So if you have a look around, you can see that nature runs a pretty amazing distributed application, right? Think about an example like a cell in your body. So all your cells have the same DNA, which is a set of instructions, and they do different things based on signals and location. So depending on the signals that a toenail cell gets, it turns into a toenail or an eyeball. But there's no controlling cell, right? There's a cell network. So if we think about how we're building Holochain apps, in the code example I showed you before, we talked about zones, and that is a set of functions and entry types. So the things that we are going to save into Holochain. And I'll just remind you what it looks like. So this is a zone, all right? Identify author. It has some code that we looked at, and it has the entry type. And those zones will evolve and change as the code in them changes. Now, if we think about DNA, DNA is a complex instruction set, and it's an evolving set of zones. So when we combined, I'm just going to flick back again. When we combine these three zones, citation, identify author, and publish with the DNA file, we get a separate DNA because it's got a bunch of complex instructions. And the way that DNA evolves is when any of those zones evolve themselves, or if a new zone comes into the DNA or one removed. So this allows the gradual change as well. So once you've got your DNA, the next thing you can do is create a cell. Now, to create an actual cell, you need not only the DNA, which is the instructions, you also need some energy and food. If you think about how a cell actually works, right? It takes in energy in the form of sugars and food, and creates all the structure of the cell, and they will work together. So in the Holochain analogy, people are the ones who supply that energy and the digital content as the energy and food. And then what happens is the cells evolve as the DNA changes and evolves. Also, the content that you are supplying into this app, and by content I mean, let's have a quick look back at Clutter. I'm talking about this. This is content that was created in the DNA, in the cell of using the Clutter app. And so Clutter is providing the DNA, which is the code, and Belinda and I turned it into a cell by using it and providing content and energy into the system. Right, now those cells evolve as the DNA and the content changes and the people in the group evolve. Because if you think about group dynamics and how people interact in a particular group, as people come and go, the dynamics and maybe the value and the output of that group changes and evolves. Now, if you think about a bunch of cells working together, it's called tissue. And a tissue will typically have a selective membrane of some sort around it and a group of cells that work together. So in this case, we're building up what I'm calling the Holochain brain. And so it's a bunch of cells that are used together. And what I mean by cells is, remember we're talking back here, which cells is the DNA plus some people. So if you have different applications, so if we have like Clutter and then we have like a chat app or maybe a to-do app, those are different cells inside the membrane. And the membrane you use to control who can access those cells. So the people that you want to be involved. And the brain tissue evolves as the cells evolve as well. Now, so we've got some brain tissue, right? Which is one group of people with some different applications. So you got so all of us in this room, we've joined the Byron Bay Holochain group, and we are using a messaging app and a to-do list app. Now, all of us in the room have gone home and gone, oh, actually, I'm going to join a different group. So I've gone home and I've joined the Holochain app developers group, which is a different set of people and a different set of DNA, because this one actually has a task management system and a peer-to-peer video system. But that's another cell. That's another piece of tissue, right? Because there's a bunch of people in there with different cells all working together. So now I've got the Byron Bay piece of brain tissue and I've got the Holochain one. And then I go and join a different group, or I start a different group and all this kind of stuff. So as you add more and more groups to your personal app, because this is not, you're not using someone else's application here. The way I'm building it is that you actually have your own version of Holochain and you add your own cells and tissue to it to produce your own multi-dimensional brain. And the reason I say it's multi-dimensional is that, think about those two groups we talked about. We've got the Byron Bay group, which has this messaging app and a to-do list, and the Holochain app, which has a messaging app and a task list. But that messaging app for me, my particular instance, goes in both of those groups. So when I go and look at the messages, I see messages across those groups. Whereas other people in different DNA will see a different set of messages because they're in different groups. And this is where the private DHTs come from. So remember I said in the hash, if you change even one thing, so if we go back and look at the DNA JSON file, if I call this unmute 2 and hash that, I will get a different, where's it gone? I would get a different hash key. So let's test that, right? Let's go to HCDev web. All right, check it out. Different hash key, and I changed 2 characters. What that means is that then I can, just by changing things like a name, you can start a whole new DHT network and invite a different set of people, which adds more tissue. So you end up with your personal application that you configure that has the functionality of all the different groups that you're part of. And this is that's the evolution part of it. And I've got this idea that, you know, like if you look at a list of messages and they're from 2 different groups, when you're reading one set of messages and then you've got that in context, if you start reading the other messages in the other group, you've been influenced by the other messages. So you kind of get this idea of synthetic intelligence across the different DHT, because as you get influenced by working in one of them, it influences the other ones. So that's what I come up with today. And we can have a chat about that. I just wanted to run through our ICO and explain to you what's going on there and why it's different. And we don't even call it any... Sorry?
I was listening to all of your explanation here. It was sort of technical about how software is developed, and it gives me the impression that there's lots of software developed by lots of people. I wasn't sure how the regular people who don't write software are going to interact. Are they going to use other people's software? Is there going to be, like, for regular users, they don't really want to know about how to make software. They just want to use software. So how do you talk to people like that? Because I would say most people in this room don't like software.
Yeah, so it works like this, right? I created the Byron Bay group, and I put the to-do manager and the message manager in there, and I knew what I was doing. And then when you join it, you get the same functionality without having to do anything. You just accept, you just follow me, and you get the same kind of application. I'm very aware of what I wanted this to be was a way to evolve software over time in an agent-centric way. So the set of DNA and tissues and stuff that I have is unique to me, as is yours unique to you, because you're in different groups. And the whole concept of this is that it's supposed to be able to evolve over time gradually. So you don't actually have to build an application, if you know what I mean. You can be parts of other groups, and they kind of do it for you, because you just join these groups with different functionality, and then you get that functionality.
So, Phil, if I can just, part of the, I mean, what I've heard the vision described as is that there'll be an app store, essentially like an app store.
That's
like
right.
the app you have on your phone. Yeah. So if you're a regular user who's not interested in developing, you can go and look at all of the available apps and download the ones that you want to use.
Absolutely.
Work pretty much like apps do now.
And then you, instead of open them in Chrome, you potentially open them in like a Holo browser or something like that, right?
Exactly, yeah. I've actually written Holo browser up, actually. So yeah, that's the idea. So this app that I'm talking about is basically the Holo browser, and you can add your own, you can just pick and choose what, I don't want to call them apps, I want to call them like a DNA library. So, because what I want people to start thinking of is this is a way for you to build things really simply. And it's not the end, right? You don't just install Twitter and then like you're done, right? You install the Clutter DNA zone into one of your networks, or somebody else does that. And so the idea is that everybody kind of evolves together and helps each other evolve over time.
And the point of it being preferred for people like us is that it's not going over the internet. So every time you type something, they're not learning, some third party's not learning something else about you that you can use. And secondly, it's always relative to that. If you create something for yourself, it's always relative to that hash that you get it. It's your ID, so no one can ever steal it or change it, because it can always be located. And then those are the two things that would be important to people who were just wanting to use it in the community instead of using the internet and having to have no option other than to go through the corrupt system that is the internet. So basically that's the gist I'm getting. Am I right?
That's exactly right. Yeah, you are responsible. You are an agent, right? So you are responsible for your own agency, and you get to look after your own data. Now, if you think about the advertising model, right? You think about the ways like Facebook works. The way Facebook works is that they gather all this data, and it's not just from Facebook, it's from basically every website that you ever visit, because you're tagged and cookied and all this kind of stuff. And they put all that data into big databases, and they run deep learning and AI algorithms against it to try and figure out what to flog you. The thing is, you could switch the advertising model around, because what the people who are selling the products, what they want is you to buy more of their product. So you could run like an algorithm on your local data, on my personal data and my DHT, and not give away any of that data because it's just running locally. And it could do things like check what sort of type of beer do I like. You know, maybe there's some sort of algorithm to do that on my personal data. And it could come back and say, you know, you like this particular type of beer, would you like to buy some? And I can press it. Right? So the product seller and the service seller has got what they wanted, which is I bought their product. And the advertising company, instead of being these creepy things that have all this weird information about us, and they basically, you know, it's like lowest common denominator. So they get all these people and they find trends, which is basically lowest common denominator behavior. And it's not really how I want to be treated. And nor should you. I don't want all my personal data being used for these purposes. I'd rather have control over what I do.
Yeah.
No, thanks.
Excellent. Yeah, and it's you know, it's all encrypted and all that kind of stuff. And you can do, we're building file sharing systems as well, and lots of collaboration tools will be coming out of Holochain pretty soon. And one thing that we have got going is our ICO. So remember before I said that ICO meant initial coin offering, And what happens typically is these ICOs, they'll come up with a good idea, they write a white paper about it, and they release a token on Ethereum, and people gamble and buy lots of these tokens, and they're gambling on the fact that they hope that the value of the token goes up over time. The problem with that is that it creates this whole speculation market. Now, I learned something just recently, and something like 99% of the value of trade in Australia on a daily basis is nothing to do with goods and services. It's all about stocks and shares and bonds and currency. So, and they're all punting on the value of the dollar and the value of different shares and things like that. So the actual use of our currency is not really what we intended it for, which is, buying things and, trading value. At the moment, it's a gambling system. So what we wanted to do at Holochain was do things differently. So we've done an ethical community offering, and we have limited the ability to join. We capped things like you can't buy more than 10% of the coins in any one go. And we did this thing called, we did an Indiegogo campaign to try and raise $200,000 to make these holo ports, we call them, as a small computer. And I think we got up to like 650,000 on that. So that went really well. ICO is going well. We're about halfway through at the moment. The difference is that we're creating peer-created value. So not everyone's going to want to install one of these crypto apps locally, but they're quite happy to use a browser and use the same sort of functionality. So we've got these holo ports which form the backbone of a decentralized hosting system. And the money from the ICO is going directly into building those. And these things are all underway at the moment. So Holochain isn't just a white paper. Like you see a lot of these ICOs come out and go, yeah, we're going to have this great idea and we're going to do this great new thing. And here's the white paper proving that we know what we're doing. And they raise like, $50 million and they haven't really got anything. Whereas we've actually got a working alpha. It actually works. We can build everything that we've said. We've done benchmarking and that sort of thing as well to prove it's exactly what we said it was. And we got this really cool idea of this sharded DHT with the validation that I showed you, that there's no proof of work or proof of stake, so there's no wasted electricity. And if you buy one of these holo ports, you can actually make money because the people who are building the apps will pay to host it on your decentralized hosting box. And that's how we get the peer-generated value, because this currency, holo fuel, is backed by the computing power that people bring to the network. So that actually gives you real value, and it makes the value of the holo fuel quite stable as well. So after the initial launch, and once the market settles on a price, we expect that the value of holo fuel to remain very stable. And once it's very stable, it makes it really good for transfer of value, which you can't really do with one of these volatile currencies, because if I go and buy a cup of coffee with Bitcoin today, and then in 2 days' time, the price, the real price to me has maybe doubled or gone down again, or because of the volatility that I showed you before. So we've built in privacy, data integrity, and this idea of agency. We want people to take back control of their digital life and own their own data and be responsible for who they share it with and how long it gets shared for. And I showed you how a fork works. If you go back and do some research on forking on Google, you'll find that these arguments go on for months. And forking is a big deal in the blockchain space. You've got all this. You've got to get miners on board, and you've got to get all the people to move over to this new fork, and then you've got twice as many coins and all this kind of crazy stuff. We actually use forking as part of our evolution. So that's why I went through that biomimicry set of slides, was to show you how at every stage we consider evolution, all of these different things. So forking for us is not a problem. It's a normal part of evolution. And the holo fuel is what's called a mutual credit currency. So all these other currencies like Bitcoin and Ethereum and EOS and all this kind of stuff, they're all token-based currencies. And so what happens is that as the miners mine and they create more Bitcoins, then that's how new coins get minted. So it takes time. It takes 10 minutes to produce, I think, 12.5 coins at the moment. And that means that as there's more demand for the coins, then the value of each individual coin goes up because there's this scarcity. There aren't any more coins and lots of people want them, so the price goes up. And then it was Christmas time and lots of people didn't want them, so the price went down massively. With HoloFuel being a mutual credit currency, we work on the concept of abundance. So the way a mutual credit currency works, and as humans, we've been doing this for a very long time, it's just double entry accounting. So let's imagine I go to the doctor and I pay in HoloFuel. The way you can actually do that is and I know there's a town in Mexico actually doing this. You can take remember an old school bank book? You can take that to the doctor and then you write in your book, I pay the doctor 5 credits, and you sign it, and then the doctor signs it as well. And then you get the doctor's book and you do exactly the same thing, except in his credit limit went up. And that's the mutual credit, because mine went down 5, his went up 5, which means the net value of the entire currency at any one time is always 0. The interesting thing about that, though, is that because it's mutual credit, and if I need more credit, let's say I paid 100 and the doctors went up 100 or 10,000 or whatever it might be, if I've got a credit limit, then the expansion of the currency happens immediately. And there's no scarcity, which means that the value of the credit will remain relatively stable. There's a website called holo.host, and that tells you all about the Holo project and the Holo ports and how to become part of the ICO. And currently we have priced the tokens that we're selling at 1/10,000th of the cost of Ethereum. So if you go and watch the benchmarks video that I'm going to link to, you'll see that we built applications that were very similar to ones that are shown on Ethereum, and we worked out what the pricing cost would be. We decided on 1/10,000th because if we tell people the real value, which is more like a millionth, it doesn't sound so plausible, but 1/10,000th of the cost. So what's going to happen is that once the network goes live and people realize that they can charge a lot less for their hosting and still make an income, then the value of each of these individual tokens should rise quite significantly. And the idea of that is to reward the early adopters, but then make a value stable currency very, very quickly. And I'm open to screen sharing with people and helping you get through the process if you like to.
Can I ask a question?
Sure, please.
You need a Holo port. Is something special about Holo port for hosting dApps compared to a regular computer?
Yes, we will give you support.
No. The question, Phil, was, is there something different about a Holo port compared to a regular computer?
No, the only difference is that we built it and we configured it, so we can support it remotely. Whereas if it's your laptop or whatever, we've got no idea what's on there, so it makes support very difficult. The other reason that we wanted to get these hardware ports out was that we wanted to have like a backbone of a bunch of computers that we knew would be online all the time. So that way we can start supplying some resiliency and helping get through different firewalls and a bunch of different services like that. And it's a way for people to actually become part of the system and actually earn some money. So if you get one of these Holo ports and plug it into your network, you'll make a return on the money that you pay.
Maybe follow-up question, but if I have a spare computer, can I use it instead of a Holo port as well by putting on the right software?
Yeah, absolutely. Yeah, if you want to support it yourself, go for it. It's really simple. The whole point of the Holo ports is it's basically a bridging solution. So right now, if you tell people about installing next-gen crypto apps and stuff like that, people are really dodgy, and rightfully so. That they should be. They should be wary of these new things. But most people are quite happy to spin up a browser and go to a URL and go and do something. So Holo gives us the ability to do that. You can run your next-gen crypto apps on these Holo ports. And as far as general public is concerned, it's just an app on their phone. just a website on their phone or their laptop, and it all works nicely for them.
So you mentioned that the cost of Holo was a fraction of an Ethereum.
That's right.
Is that right?
Yep.
And so Ethereum is changing value. Is the value of Holo changing?
Yeah, what we did for the ICO was we worked out a reasonable price for Ethereum over the period of the ICO, and that's what we're sticking to. So, and it hasn't varied too much. You know, it went down a fair bit, which hurt us a little bit, but it's coming back up now. So we reckon by the end of the month, which is when the ICO finishes, it should have just about averaged out. And yeah, so you will get you'll get exactly the right amount. And like I said, even though it says 10,000, it's actually a lot more than that.
Phil.
Yep.
Because I'm in the room, is it easier for me to just help handle some questions if I think I know the answer? They set a benchmark at the beginning of the ICO for the price of a token, and they're holding that constant for the month-long period of the ICO.
At a US dollar value?
At a fraction of an Ethereum.
Yes, but right now, what do I pay? Do I pay a value compared to a US dollar, or a date that Ethereum was valued to US dollar?
Yes.
So how much dollars is it? Is there a dollar value right now that Holo is worth?
It's Phil. Is it 10,000 Holo tokens per euro? Am I right about that?
Yeah, something like that. I think it's more than that.
So they're small, tiny.
Then
Yeah, I got like 80 million of them for.
So the value. So as the network comes online, there's a kind of a market established.
Yeah. So what's happening is that until the end of the ICO, you actually can't trade these tokens. And it's a two-stage process. So we are selling ERC20 tokens to raise the funds to build Holo Fuel. Once that network goes live, we will change the ERC20 tokens, which are called HOT, by the way. So we'll change those HOT tokens into Holo Fuel once the network goes live. And we're expecting that early adopters who buy into this process will make a reasonable return.
But have you set it like 5% per annum, or is it stable, or is it something that will go up in value according to another metric?
It will be set by the market price that the host has set. So everybody who buys one of these Holo ports or runs Holo is part of the decentralized distributed hosting network, and they can set the price that they charge on the hosting. So what's interesting there is that the difference in hosting cost between hosting an application on Ethereum and doing a similar thing on like Amazon Web Services, we worked it out as something crazy, like it's 40 million times more expensive to do the same thing on Ethereum than it is on AWS. So we figure that there's quite a big margin there for us to be able to supply this service at a much lower cost than Ethereum, but still give you all of the cool stuff that Ethereum gives you, like, you know, next-gen crypto apps and trustless systems and that sort of thing.
Okay, so will Ethereum smart contracts be able to be moved across to Holochain?
You could do, but I wouldn't, because as far as I can, because I've done some Ethereum programming and it is just horrible. You wouldn't, the way that the Ethereum code gets written has to munge it into this system of mining and block and gas limits and all this kind of stuff. So
you start fresh.
Yeah, absolutely. I mean, you saw how easy it was to write an app. It's just JavaScript, so you can build these apps really quick. And like Nico was saying, if you think of these apps as a language, so you install this different language on Holochain and then you can talk to people differently. It works a lot different to Ethereum.
So what's the primary call to action? To make money? Or, so for example, let's say like LimeWire, let's go back to like BitTorrent, like you download those to get free music.
Yep.
What's the call to action for Holochain? Is it to make money out of a currency, or is it what's the call to action for it?
Okay, so I heard somebody before talking about currency design. The founders of this project are long-term currency designers, like community currency designers, and they wanted to build a system that they call meta currency, that they could simply create new currencies to deal with different situations. And tried several times and ended up with building a system called Scepter, of which Holochain is one of the sub-projects. So all these other, like a lot of these other ICOs and stuff like that, their white paper and their product is really the end of the line for them. That's what they're going to build. Whereas Holochain for us is just one step to getting towards this idea of meta currency. And what it does is, so Holochain is designed to be a unenclosable communication platform. And what that means is unenclosable communication is like you guys are all sitting in the room, and if you start talking to each other, there's no way that anybody else in the room could stop your words actually getting to someone's ear, right? You can't just pull them out of the air. However, if you don't want to listen to me anymore, you can just pull the connection, right? So your communication is unenclosable because no one can stop you talking, whereas mine, because I'm out of earshot, basically, mine is enclosable.
Okay, so it's security and liberty of it's like privacy. Like what I'm trying to figure out, like, so the reason that things have reached critical mass, obviously, like Bitcoin, was that it was something that was attractive, that pushed people towards it. It reached this point where all of a sudden people were rushing at it. What is that primary reason that people are going to rush towards Holochain to use it? Is that right now as a source of income, or is it more that privacy and liberty issue and agency?
No, we don't want the big rush kind of. This is we're building a gradual process so we can gradually increase the community and lots of people can use it. We will make some money from the Holo port situation because we're going to charge us a very small transaction fee, like less than 1%. And we don't want people gambling on this. So that's the whole reason that the ICO has been so controlled.
But it also, for it to be like an effective network or a platform or membrane or ecosystem, you want diversity. And if you're going to have diversity, you have to have a lot of cells.
Yeah, absolutely. And
all I'm trying to think of is what's incentive? What's the incentive for people to populate the space?
The incentive is that lots of people want to write these crypto apps, and they're using things like Ethereum and Stellar and EOS and all these kind of blockchain technologies. And what they're all finding is that they all run into these scalability issues, right? And because, and they're using this new technology, but still thinking old school, like having somewhere where your data is rather than you looking after it. So Holochain gives you a different way to build applications. You can build agent-centric applications that are eternally scalable. You know, running a Facebook kind of app on Holochain would be quite simple. And yeah, that's the thing, like it's a different way to program, and it gives you this ability to evolve software over time. And it's like we've got all of the tools there to build apps really fast. I mean, if you've ever tried to build a smart contract, I mean, that is just no fun at all. This is really fun programming.
My answer to that, the sort of honing what Phil's saying, is that no one else is doing an agent-centric approach. Everything else is data-centric. And so that's where the major flaw is for most of these other platforms.
So,
and even when they're doing like next generation blockchain, whether it be hash, graph, or what have you, they're all still data-centric. And so bringing in the human element, the nature element, the agent-centric element is what separates this from everything else.
Yeah, but I feel like the world's still stuck in like the capitalist, like growth, need to see growth mode.
No, people have to live.
Yeah,
When it is the point here, people have to live. So how are they going to live if they convert into this platform? That's all that's happened through evolution. We've learned to try and find different ways to earn either food or money to buy food.
Yeah, and that's what I'm trying to find out. Is like what the call to action is. So like, I mean, I get that. Like, I'm not trying to undermine that conversation about what you're saying is that it is a really great place. It's deep. I'm all for the decentralization, but the call to action still seems a bit fuzzy for me. Like, it's still.
So the call to action is that it's this unenclosable communication layer, and that we've given you Holochain. You can build whatever app you like on it and have whatever people you want involved. You can coordinate and collaborate really easily building these applications. So this is going to give rise to a whole new way of thinking about things, which is this agent-centric approach where people take responsibility for their own data and basically their own behavior online as well. Because, you know, if people build their own digital presence by evolving with their peers and that sort of thing, or adding their own stuff, they become quite precious about it. You know, you're not going to want to go. I'm hoping that this kind of agent-centric approach might reduce the amount of trolling and like cyberbullying as well, because you don't want to get forked off the network because people don't want to talk to you anymore. You know, it's much easier than the systems we have at the moment.
So, Phil, my observations, I just want to tease out the implications of this phrase agent-centric a little bit. So for me, what it means to switch from a model where the data is the focus of everything to a model where the agents or the, you know, literally the actors are the focus of everything is a completely different emphasis on trust, personal power, and responsibility. So it's actually my sense. Phil, please tell me if you disagree with me.
No,
my sense of some of the important intentions behind this project are around creating an ecosystem that will encourage and support different kinds of behaviour, different kinds of connections between people, different ways of interacting, and also different ways of even thinking about and certainly representing and allowing the exchange of value within social systems.
So can I ask for a project, and can you tell me sort of how it fits? Let's say I want to make a car pooling, car sharing network, and I want people to participate, and a handful of people sort of like cobble together something useful that can be accessed through a browser, and another bunch of people, all they want to do is like find someone who gives them a lift. They want to find a car that they can hire from the group. So most people just want to access the network and communicate and coordinate, and some people sort of want to support that network through making sure that there's a facility for them to access it through a web browser. Would let's say 99% of the people, let's say 99.9% of people, do they need to know that there's Holochain existence, or they just need to know there's a web address they can go to?
That's exactly what the whole Holo thing is about, because it's the bridging step. So now people can just go to a URL, and we're going to have a distributed DNS, so you're not going to go through ICANN and that kind of stuff. So it'll be completely decentralized as well, which again stops it from being able to be controlled. So yeah, people will build their own apps. You're exactly right.
Okay, so I'll take it to the next level. Let's talk about the governance idea, because it sounds as though everyone who accesses this type of thing can decide how much they want to interact or not. If people start using this network, can they just start using that, just fork that network? Or is that something that the 5 people who sort of put it together in the first place, can they say, well, this is not open source, it's not available for everyone, you can use our network, but we're still governing it, we're still governing the software, you can either use it or not use it. Is Holochain something that decides that it has to be open source and that you can fork it, or what?
No, you can do whatever you like with it. Everything is open source. The way that these Holo apps are going to work is that if you're a business and you want to maybe sell access to your modules, or you want to provide a service in a particular group, you can just run your own version of the DNA library.
All right.
And yeah, the whole thing's done under the MIT license, so you're free to do whatever you like and build. This is one of the fantastic things about Holochain is that, remember in the video before, Nico was talking about how you could build blockchain on top of Holochain, because blockchain is just one thing you can do with Holochain. Right, so that's the thing, right? With this unenclosed communication layer, you can build whatever you want.
Does that like also mean that like pedophiles could get on and set up like
Yep. Exactly like they do now.
There's no police.
So there's no so it could go a bit dark web in a way as well. So you could end up having.
Yep.
It would go dark web. But here's my question. Sorry, I'm not. Sorry, if you want more to speak, I'll wait for you.
No. I mean, I guess then, like, there's no way to ever stop someone doing something horrendously bad through Holochain. There's no way to be able to intervene in some type of something.
If a bunch of people get together and want to build their own app or use existing apps and have their own network, that's the whole point. You can't stop them. And none of the prohibitionist stuff on the internet works in the slightest. But the vast majority of it is people doing good, and that's what humans want to do in general.
Yeah. I think once you open that gate to moderation or censorship, it's always a downhill slide from there. So I get what you're saying, but the whole freedom of speech thing is freedom of speech from what I consider this.
Well, the tax department will be after you. And also the police will be after you. If you do a crime, they're going to go after you whether you're on a dark web or not.
Yeah, exactly. Yeah.
But here's my question back to you again about the application of a carpooling, car sharing. It sounds, from my point of view, of let's say a community wants to share software in order to interact with each other. They still need to sort of get the software happening, and the reason why they might want to use Holochain over something else is sort of, it sounds as though it might be easier to host it or cheaper to host it than a blockchain, but is it cheaper to host it on Amazon? Is it something that a community would want to use Holochain, or so they just go onto Amazon and have someone write the software?
But then
you can do a different
solution, it defeats the purpose, right?
Well, can you tell me, is there value for this community to use Holochain, or is it better they just use regular software at Amazon? Does Holochain somewhat sync with the fact this is a group of members that get together that want to cooperate? That's back to you, Phil.
I think the question if you want to have it cheap or censor resistant and still be the owner of your data. So that's either one or the other.
Well, we're using private software amongst the community, and we could use this hosting anywhere, and we can use open source. Is there a reason to go to Holochain, or is it good enough that I just find cheap hosting and open source software, and that we don't share the data with a third party? We just, members get the access. Is Holochain going to add a dimension for us or not? That's what I'm sort of wondering. We're not going dark. We're not trying to hide from anybody. I mean, we're not trying to hide from
because it does work faster. Like it's the experience for the agent, because with Holochain you get to look after your own data. Okay, that's the main thing. It's agent centric. The development process is very similar to working on AWS Lambda. We use microservices architecture. Very similar idea, except that instead of having a central location that you hit a web server, you run the web server locally, and then your DHT takes care of moving the data around.
So when you compare to Ethereum hosting computation, you really should be comparing to Amazon and saying whether it's better than Amazon.
Well, Amazon doesn't provide next-gen crypto. It's just a web server.
But I can direct you to a YouTube video where there is like a 10-minute comparison using Amazon Web Services as a Holo analogy.
And what was the
doing
result?
a more
Just
direct.
to give me the summary, is it better for a group of people to use Holo hosting than Amazon?
Well, so it depends on how Holo ends up being priced, right?
Oh.
But I mean, it does depend on the price. These guys think that they've done their sums so that that Holo will work out to be cheaper. But the other difference is that if I pay Amazon Web Services to host my application, then I'm paying them.
Yes.
If I have an application that is shared by members of my community and we host it ourselves, then we control the data and potentially we can earn actual money by hosting it
Hosting other
ourselves.
software.
Well, hosting that app ourselves and other software as well, potentially. So there's
Hosting currency.
yeah. So with our participation comes
Values of exchange rather than currency.
So is that the use case for the token coin, I guess? Like,
yeah. So I have Matthew Schutte did an intro to a Q&A a couple of days ago, where he talked about Holo as something like a project that is designing a decentralized distributed version of Amazon Web Services that regular people can participate in and therefore profit sharing.
But why couldn't I set up, or why couldn't I be a Chinese manufacturer of Holo ports, set 20,000 of them up in factories in China with VPNs, and make a shitload of money out of hosting?
So people can't.
You can do that.
So yeah, what like?
you can't because you're not Chinese.
But don't forget, then you've got other things.
Can you make you're still sharing your screen? It'd be good if we could see you. Do you reckon you could?
Actually, I might just stop the recording now.